Hi guys, myself Manoj.M. In this video, I am going to explain you about the NAND and NOR gate. In this video, we are going to discuss about the NAND and NOR gate symbol and then the working and then finally the truth table. Okay, NAND and NOR gate. Yeah, NAND. That means the gate formed using the NOT gate plus and gate. Okay, the writing of the symbol is very easy, guys. Simple. First, you should write the AND gate symbol like this, and then add bubble here. That's it. Here it's A, it's B, it's Y. Y is equal to A dot B whole bar. Okay, the output will be A dot B whole bar, and then let write NOR gate symbol here. NOR, it is simply not place or gate. Okay, that's it. This is A, this is B. Let write OR symbol. Same thing, and then add bubble to this. Output will be mentioned as Y. Okay, Y is equal to A plus B whole bar. Okay, that's it. Yeah, let us discuss the working of these two gates in a simple way. Yeah, guys, we know that in the AND gate, the output will be 1 only when both the A and B are 1, otherwise 0. But in an AND gate, if any input is 0, the output will be 1. If both the inputs are other than 0, that means 1, the output will be 0. Okay, yeah. Yeah, let us write this here. In NAND gate, if any input is 0, then output will be 1, else output will be 0. Okay, let us discuss about the NOR gate. We know that in the OR gate, the output will be 0 only when both the inputs are 0 0, otherwise the output will be 1. But in the NOR gate, if any input is 1, then the output will be 0, otherwise the output. Yeah, let us write this in NOR gate. If any input is 1, then output will be 0. Okay, else output will be 1. Okay, yeah. Guys, the NAND and NOR gates are universal gate. NAND and NOR gate or universal gate because we can make all kinds of gate using the NAND gate and also by using the NOR gate. Okay, yeah, let us write the truth table for NAND gate here. Truth table, yeah. A, B, Y, yeah. 0 0 0 1 1 0 1 1. Okay, yeah. Yeah, you can see it in the working also. If any input is 0, then output will be 1. Yeah, you can see 0 here, then the output will be 1. You can see 0 here also 1. Here you can see 0 here also 1. Here it is 0. Okay, that's it. or also you can write the complement output of AND gate. Okay, that's it. Yeah, let us write the truth table of NOR gate here. Okay, truth table A, B, Y, yeah, 0 0 0 1 1 0 1 1. Okay, yeah. Here you can see the statement. If any input is 1, then the output will be 0, else it will be 1. Yeah, you are not seeing 1 year and then the output will be 1. You can see 1 year, the output is 0. Here you can see 1, the output is 0. Here you can see 1, the output is 0. Or you can write the complement output of the OR gate. Okay, that will become the OR gate. That's it. We are putting the inverter, right? That will give the output as if we give 0, that will give 1. If we give 1, the output will be 0. That's it, like that. I hope you clearly understand the concept. Yeah, we also learned that the NAND and NOR gates are the universal gate, because by using these gates we can implement any other gates by using these gates. I will explain in the separate video. Okay, I will explain that NAND as a universal gate and NOR as a universal gate in another video. I hope this video helps you. If this video helped you, hit the like button, and if you didn't subscribe my channel, please subscribe my channel and click the bell icon. Okay guys, I hope this video helped you. Thank you for watching guys.